3.2, Applications of Maxima and Minima. Problem number 2. The budget for fencing is $120 to design fencing along a wall with 2 areas where the width of one side is 1/3 the width of the other. Now the cost of fencing for the adjutting sides is $4 per foot. That's these sides right here. While the front side of the fencing, from here to here, is $3 per foot. We want to find the largest area that can be fenced. Okay, so let's rewrite the problem here and see if we can label this. There's the fencing. Now, since we're trying to maximize the area, I want to label all of this. This side to this side, since this is $4 a foot, we'll label this X. And this will also be $4 a foot, so that's the same size X. And the same size X there. This side, which is $3 a foot, I'm going to label this Y. So from here to here, that's Y. This piece right here, we're told, is 1/3 the width of the other. So 1/3 of this width will be 1/3 Y. Now, we're trying to maximize the area. So I want to start with the area formula, and we want to take a derivative of that area formula. So we can set it to 0 and see if we can solve for the variable that maximizes it. Area for a rectangle is length times width. In this case, our length is from here to here. That will be Y plus 1/3 Y from here to here. And my width is here, which is X. Now I'm going to simplify Y, 1Y plus 1/3 Y gives me 4/3 Y. Then times the X. Okay, I cannot take a derivative of the area right now because it has 2 variables. So what I need to do is I need to replace one of the variables and put it in terms of the other variable. So I need some permanent information for that, and we do have permanent information that 120 is the budget for the whole project. So let's see if we can set up everything equal to a $120 budget. Okay, for the fencing along here to here, we're going to pay $3 per foot. So how many feet do we have? So I need to add from here to here, and then multiply that times $3 per foot. Okay, so it'll be 3 times adding Y plus 1/3 Y. Plus, I need to add up how much it's going to cost for each of these adjutting walls. I have 3 of them, so that's 3 X's. And I'm going to pay $4 a foot for each for those. Okay. Now I want to simplify this expression. So I want to add the 1Y and the 1/3 Y. And I'll also multiply the 4 times the 3x. Okay. From here, the multiplying 3 and the dividing 3 cancel, and I'm left with 4y. From here, I'm going to solve for y so I can replace this y here and make everything in terms of x. So I start by subtracting 12x from both sides. And from here, I'm going to divide both sides by 4. Now y can be replaced with 30 minus 3x. From here, I'm going to distribute my 4/3 into the function, and then I'll distribute my x. I'm going to distribute my x, but I'm now showing that this is now all in terms of x. Now we want to take the derivative of ax, and we get 40 minus 8x. Now from here, we want to set this equal to 0 and solve for x. I'm going to add 8x to both sides. And then I'm going to divide by 8. I have that x is 5. Now I'm going to substitute x or 5 into x here and solve for y. So this gives me x is 5 and y is 15. So going back to the original question, what is the maximum area, sorry, the largest area? I go back to my area formula, which is length times width, and that can be found by 4/3 of y times x. So that would be 4/3 times 15, and then times x, which is 5. Okay, and so that will be 15 divided by 3 is 5. 5 times 5 is 25, and 25 times 4 is 100. So the maximum area would be 100 square units.